Hello class, welcome to Geometry Chapter 8 Review. If you're watching this video, that means that you're attempting to study, so good job. You're not being like any of these people listed on this first slide. Now, let's jump into it and say Geometry 8.1. Feels like it was a long time ago. That was all about right triangles and Pythagorean theorem. So that means that we talked about the special right triangle. So the first special right triangle that we'll talk about is our 30, 60, 90. Make sure you memorize these formulas. Our short side of the triangle is always just x, okay? So if we call that x, then our hypotenuse, the side that does not touch our right angle, is 2 times the short side, and our long side is the short side times the square root of 3. So you might want to go back and try some of those problems if you're like, I don't really remember any of that at all. Go back into your assignment, retry some of those problems. Or even Google 30, 60, 90 triangle problems and then solve them. All right, then we have the 45, 45, 90 triangle, which is isosceles. That means that we have 2 side lengths that are the same. We call both of those x. And the hypotenuse on a 45, 45, 90 is the short side times the square root of 2. Again, if you need a refresher on that, please be sure to go back to either the 8.1 video or the assignment and try some more. Or ask me for help. You know, I do like to help you guys. The Pythagorean theorem, we've been talking about this for a couple of years now. We have our right angle, and A and B can be interchanged. This side could be B, this side could be A. It doesn't really matter as long as you don't choose the hypotenuse. So you say our 2 legs, if you square them and add them together, it equals the square of the hypotenuse. So make sure that you're just plugging everything in the correct place for those problems. That's the biggest mistake I see. And then the converse of the Pythagorean theorem, that's when I give you like 3 numbers, 3 side lengths, and I say, do they form a right triangle? So you say, what is our biggest number? That's 5. I'm going to put that by itself, and then I'm going to put the other 2 sides together. And then you see, is this true? If it's true, then it's a right triangle. If it's false, it is not a right triangle. Okay? So that's 8.1. 8.2 is our SoHCA. It's trigonometric ratios. So that's where we use SoHCA. I have it written out there. Remember, I will not give you any of this information on the test. You need to know this. So is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then if you're solving for sides, you use the regular sine, cosine, and tangent. If you're trying to solve for angles, that's where you use your inverses, okay? So those are 2 mistakes that I see people make. Make sure you only use inverse to solve for angles and only use the regulars for sides. The second biggest mistake I see with SoHCA is not properly labeling the sides. So if I'm looking at this angle, that means this is my adjacent, this is my opposite. Remember, adjacent helps form the angle. The hypotenuse always stays the same. It's the side opposite of the right angle. And then if we're looking at this angle instead, this one would become my adjacent because it helps form the angle. And then opposite is the other side. Okay, so make sure you're paying attention to what sides you're using. Now, law of sines. Law of sines, a lot of you have asked me, when should I use law of sines? Often if you have 2 angles and 2 sides, or let's say you have 2 angles, 1 side, and you're solving for a side, you would do law of sines. If you have 2 sides, an angle, and you're solving for an angle, you're still going to do law of sines because you have enough to plug in. Remember, law of sines, you only have to have 2 fractions set equal to each other. So if I said that this was 80 and this was 4, and then I said that this is like 42, and I wanted to know what this is, all you would say is you would say sine of 80 over 4, because those two line up, they're opposite from each other, equals sine of 42 over x, and then you would solve for x, okay? If you need a refresher on how to solve for x, be sure to ask for some help. If, let's say, this was like 2, and I wanted to know what this angle was, the way that you would set that one up is you would say sine of 80 over 4 equals sine of x over 2, and you'd solve for x, and at the very end, because you want the angle, you have to take the inverse. So you take the inverse of 2 sine 80 all over 4. And when you plug that into your calculator, make sure you hit second sign, and then it's automatically going to open that first parentheses. I want you to put a second parentheses in there to open up the top of your fraction, then hit sign, open, or your calculator automatically opens this next parentheses. So you're going to close the sign parenthesis, close the top of your fraction, the numerator parenthesis, then you hit divided by, type in 4, close the parenthesis. Okay, so make sure you're careful on how you plug things into your calculator to solve. So law of sines, I will ask you to solve for a side in one problem, and I will ask you to solve for an angle in one problem. So you need to make sure you know how to do both. Now, law of cosines, that is going to be used when you have a side angle side situation. So let's say that that's 3, that's 4, and this is 111. And I want to know what A is. The way you would set that up is you'd say A squared equals, B and C can be interchanged. You can say 3 squared plus 4 squared, or you can say 4 squared plus 3 squared. And then you do 2 times each of those, and then times cosine of whatever angle you were given. In order to get A by itself, when you solve for a side, that's when you end up doing the square root of whatever number you were given, okay? So you could plug that whole thing in. I recommend simplifying this. So instead of writing 3 squared plus 4 squared, I would say 25, and then I would change this to be a 24, because 2 times 3 times 4. And that way, there's fewer things to plug in and mess up on with your calculator. I will say that you have to show me your work on this problem in order to get full credit. So you need to practice how you would set things up. So I expect to see something like that. Now let's say I want to solve for angle A. So I'm saying that this is maybe 7. The way I would solve for that is, since 7 is opposite the angle I want to use, so again, side, side, side is the situation we have going here. Side, 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 solving for an angle is going to be law of cosines. Okay, so anyways, x is opposite of the side 7, so I'm going to say 7 squared equals 3 squared plus 4 squared minus 2, 3, 4 cosine of, I can say x, because that's the variable I used. So I'd have 49 equals 3 squared plus 4 squared is 25 minus 24 cosine of x. Be careful. A lot of people say that, oh, hey, 25 minus 24, that's just one cosine of x. That is not using order of operations. Do not do that. Do not be that person. What you need to pay attention to is 24 is being multiplied with cosine, so we cannot break that apart. What I can do is I can subtract 25 from both sides. So then I am left with 24 equals negative 24 cosine of x. I would divide both sides by negative 24, so I have negative 1 equals cosine of x. So then you would say, in order to get x by itself, you do the inverse of negative 1. Or a lot of times those numbers don't match, and say we had like a 27 there. this doesn't match the problem, but I'm saying what if we had that situation? What you would plug in is you'd have 24 divided by negative 27, and that's what you would plug in to your calculator to find the angle. However, that's not the way the numbers worked for this exact problem. So we would have, that's a negative 1. So you do inverse cosine of negative 1, and then whatever that answer is, that is what your angle is. Okay? So law of cosines you use in a side angle side situation or side 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 situation. Anything else that's a non-right triangle, you're probably going to do law of sines. So that's something I forgot to mention on law of sines. Law of sines and law of cosines are only used on non-right triangles. And the last section in Geometry 8.5 was problem solving with trigonometry. So we have basically just two things that we learned in this lesson, and that was angle of depression and angle of elevation. So angle of elevation is when you have a horizontal line and your angle opens up. And angle of depression is when you have a horizontal line and your angle opens down, okay? There will be some problems where I give you a picture and some problems where I say you need to draw a picture to solve. So make sure you feel comfortable with both of those. Then you're typically using SoHCA to solve those. Rarely will you end up having to use law of sines and law of cosines, but it is possible. And then on your test, you will also have one of those cell phone problems, so make sure that you're asking questions on that if you're still unsure on how to solve that. I'm not going to do one in the video just to save time, but good luck on your test. I know that you guys are feeling a little overwhelmed about this test, but I know you're capable, and just make sure you study, make sure you ask questions, and you will be just fine. Have a great day and happy studying.